So we have something happening here. So I see the screen now, but not your slides yet.
Okay, so hopefully everybody can see the the screen. Thanks, Joel. Appreciate it. And I want to take you through an example of what I think is an example of statistical engineering that works for me and happened pretty recently. I've been a consultant over the last just about 10 years, and so having been mostly in the Lean Six Sigma business since I don't know, around 2002. I don't always get a lot of chances to do statistics. A lot of my work, honestly, is in helping people draft up project charters and write good problem statements and so forth. So it was with particular relish that I got to be able to do this. So what I want to do is I want to take you through this. If you have questions at any point, feel free to interrupt me. I guess Joel will be the one who will be interrupting me, which is fine. And it just seems to make sense if you have questions as we're going through it. Apologize ahead of time. I had kind of a rough night last night. My hard drive had an irreparable crash, and so I scrambled this morning to put together my data. Luckily, I back up my data fairly regularly, so I had to put together a PC so I could talk to you guys today. So a little bit bleary-eyed at this point. Okay, and so the sun's in my eyes. The ball took a bad hop or whatever. Enough excuses. Okay. Here's what I'd like to talk to you today about. First of all, take a few moments to talk about what is statistical engineering and statistical thinking. And then take you right into the example application, which is I've called it sampling sampling of the supermarket stats, but this is sampling for a food wholesaler. And I'll take you through a little bit of the background so you can understand what the study was about and what the work was about. And then I'll take you through the work, through the initial study, which was initiated by a call from a senior exec, and then through a pilot, and then full implementation. Talk a little bit about wrap up, and then hopefully have a little time to field your questions if you have them, and I hope you do. Okay, with that, I think I will start to walk through. So let's start out with statistical thinking and statistical engineering. So Roger Pearl and Ron Snee in 2010, they're the folks who really kind of brought this back into the forefront. They didn't originate the term. Certainly it was used before, but they have been really the primary movers recently of that. In 2010, defined it as the study of how to best use statistical concepts, methods, and tools and integrate them with IT and other relevant sciences to generate improved results. Okay, so there are a few things that are key in there, and that is that, first of all, that statistical engineering does involve statistics. The parts list, as they would say, comes from statistics. However, it collaborates with lots of other sciences and pieces of business and needs to produce something of value. Additionally, if any of you were also at the NASA conference earlier this year on statistical engineering, both of them pushed the point, and I think rightfully so, that it's often applied to complex, unstructured problems. So we're not talking about that helps just make the distinction between, say, applied statistics and statistical engineering. One might say, hey, I have a regression problem or a discriminant problem or a problem that requires a t-test or something like this. That might fit easily into applied statistics. Statistical engineering, however, involves making sense of it in the real world and applying it. applying it in the real world to something where it isn't necessarily obvious what's the right analysis or what's the right approach to put together. Contrast that slightly with statistical thinking, which is a philosophy of learning in action based upon the three fundamental principles that all work occurs in a system of processes that are interconnected, that variation occurs in all processes, and then understanding that variation and then reducing it is a key to success. Now, it's not the only key to success, so there are other things as well. If it were the only keys for success, we would always go to McDonald's and never to Morton's Steakhouse. Even though I'm a vegetarian, I prefer Morton's. Okay, so anyway, so that's the background. Hopefully that all makes sense to everybody who's here. So let's take you now through the application itself, and I'll start with the background. So for those of you who are unfamiliar with the industry, and I certainly was before I got into this, the supermarket, let's take you through the supermarket supply chain using kind of statistical thinking. Let's think about how all these processes are interconnected. So the idea is essentially connect what we bring home at the supermarket, that is over here where the red ball is, as consumers, currently consumers with a funny hairdo. We get from the supermarkets. Where does that come from? Well, the producers produce it, that is the farmers and ranchers and so forth, and the manufacturers, the canneries and so forth, will put it together, get it to the wholesalers, who then warehouse it in different areas. The trucking companies then bring it to the various end customers via stores like Big Bear, Whole Foods, Stop and Shop, Safeway, Piggly Wiggly, or whatever is your favorite. Now, in a lot of cases, a single, like in the old days, A&P kind of pioneered owning the whole supply chain. So they literally owned a lot of the producers as well as the manufacturers and the wholesalers and so forth. They were able to cut costs that way. Nowadays, it's a mix. So you have companies like Safeway who own the warehouse operations and many of the supermarkets. You have companies who are wholesalers who own the trucking companies and so forth. Okay. Now, in this particular study, in this particular piece of work, the warehouse was the client of ours. So we did this work on behalf of a food wholesaler. They did some manufacturing, but mainly they were the distributor. They also owned some of the trucking company. But the key relationship was between the wholesalers and the supermarket. And we'll call that, I'll kind of fall back and forth into using wholesalers and client, and I'll fall back and forth into using supermarkets, customer, sometimes I'll say grocer as well. But the key relationship is between the supermarkets and the warehouse. Now, the trucking company, which is appearing as a ghost here, comes into play a little bit later as we'll go through some of these results. And it certainly was an important piece in the statistical design for consideration. Okay, a little more background, just like any problem, and I think that this is kind of an important thing to think about when you're doing statistical engineering, is to map out who are the various voices or constituents or players at each of the clients or customers that you have. So on the wholesaler side, we've got executive management, corporate management, regional management, and the auditors themselves, and they each care about different things. For example, executive management, which is comprised of people like the CFO, the COO, and so forth, they have very different goals than the auditors themselves, who are certainly worried about the day-to-day operations of their own job. So it's a very different ballgame. And you'll do well to kind of remember that each of those constituents has a different expectation, and the engineering that you put in depends on who's going to get it. And you have similar sorts of things on the supermarket side as well. So just to kind of go quickly through this, I want to make some distinctions here. So executive management, I mentioned, was the CFOs and the COOs, CEO in occasional meetings. Corporate management, I make the distinction of, because these are people who work for corporate, they may be director level people, sometimes assistant vice presidents, that sort of level. They tend to be lifers in the company, whereas executive management is sort of mixed. This is, I'm finding, is pretty common in a lot of companies. The corporate management, being lifers, they have different concerns than the executive management do. Then there's regional management, and those are the people who essentially used to be the auditors, but then they became super auditors and maybe are in control of a few of the auditing at a few facilities, and they kind of manage that semi-locally. And then at the bottom of the chain, you've got the auditors themselves, and these are the people who lift the boxes and count the boxes or cases of food. On the supermarket side, you've got similar sorts of things. The auditors in this particular case, I found out through the pilot, actually work alongside and kind of hold the auditors, the wholesaler auditors, to task. Okay, hopefully that's enough background. I think we ought to get kind of into what the study actually was. So let's get into it. So the way that it started was that the wholesaler executive, who happened to be the CFO, asked Straight Line, or one of our partners, kind of in a roundabout way, they didn't ask it maybe this directly, the question of, hey, could you guys help us determine if we're auditing too much or too little? So they kind of asked the, and can we reduce the amount of quality audit sampling that we have, or they called it load audit, which is literally pulling over a truck that's meant to go out, opening it up, and looking at its contents. Can we reduce the amount of quality sampling that we have and still maintain accuracy and precision? All right. Let's see. Okay, I think it was there. Oh, there's a couple of questions about downloadable slides. The slides will be available some point after the talk. Okay, let's see. Okay, so he asked it in a kind of roundabout way, but you can see that this is sort of a classic sample size question, right? So we might say at this point it's applied statistics, and we'll see how that changes. Second question was, can we recommend a standard, reliable, and efficient sampling implementation for them? And the third one was a very, very specific tactical question, and that was, can we use a scan gun to look outside the packages to see and estimate what's in the pallet. And so you can see that these are questions of at least a director level and probably an executive, where they're asking questions that are really related to efficiency, margin, and so forth. They're thinking about the customer. They're thinking about corporate profitability. Just so that we're all on the same page, here's what we're talking about. This is something that a picker or selector would put onto a pallet. You can see it's shrink wrapped cases of food. You can see Bounty paper towels and Arizona iced tea and so forth. And you can see that they've done a reasonable job here of in some ways, of packing this, where they've got the light things on top. That's good. That's good procedure. In any event, this is what we're talking about. These are the things that would be picked from a warehouse. You can see the warehouse in the background. The selectors would put them on a pallet. These pallets would be loaded into a truck and then shipped out to the supermarkets. And every once in a while, a truck would be pulled, moved into a bay, and they would take it out and count boxes. Cases. Okay, so that's what we're talking about. So our approach to this was essentially to evaluate some historical data. In this case, we looked at data from June to from June to June, about a year and a half ago. Evaluate it and evaluate the existing documentation and the current processes. Develop some workflows and validate them. Perform a comparison study of sample sizes and nonconformities across facilities, and recommends optimal sampling amounts and procedures. So you can see here that also we're using a lot of statistical thinking in terms of saying, okay, we're looking at the workflow itself. We're seeing how what we end up as a result for our nonconformities. We all know is how we measure something is going to depend on what the values that we get or the results that we get are going to depend on how we measure something as well. So at this point, we did a fairly high-level analysis. The funding wasn't there to be on site. It was just kind of a look-see to come in and say, hey, are we more or less on track, or should we be thinking of something else? So we decided to take a look at it, and when we did, here are the number of different facilities that are located that are listed here, or that are presented on the x-axis. Each one of those bars represents a facility. They're whited out for the purposes of the presentation and anonymity of the client. Excuse me. In any event, you can see from at a glance right away that you've got a tremendous variation in the amount of sampling that's going on. You've got one site that's sampling over 3 million cases and another that's barely scratching the surface, a number of them that are barely scratching the surface. And so, we decided to say, okay, so what are some of the drivers of that? The most obvious one that you usually think of, whether it's correct statistically or not, is volume. Very often, companies will have a straight percentage. We're going to sample a certain percentage of cases or a percentage of trucks, and it's driven by that. So we put together our own map, and the first time around, we were able to look at it by facility. We added in our analysis, looking at it by nonconformance rate. We also looked at it by customer chain, by building over time, and so forth. So built up that whole idea of what's really driving the number of cases samples. And I've left a few blanks now because we're going to do parts 2 and 3 as we go along, and we'll learn quite a bit. Here's another example of what we ended up using. Actually, was we ended up looking at the absolute maximum proportion of nonconformities. And what had prompted this actually was an internal analyst had said, hey, let me take a look at the sample size. And he had estimated the sample size, but he hadn't put in a good estimate for the proportion. He had used 50%, and as we all know, that's the most conservative number. And it was still a tremendous decrease. And so when we looked at this, the maximum that we had in any week was on the order of 8% or so. And so we knew we could provide a tremendous advantage in that. So in fact, if you take a look at it, we had a couple of different recommendations. One was a very simple, straightforward recommendation, which was to use a conservative 10% because they weren't ready for a tremendous decrease, but a conservative 10% across the board, or to use a by facility percent as well. So you can see the original is in purple. The one that the internal consultant or analyst recommended is in the black. The yellow was our recommendation, and the green was our recommendation B, aggressive, more aggressive recommendation. You can see that most of the advantage is gained by going from the purple to the yellow. I guess Minnesota Vikings, if you're into that sort of thing. That represented the capacity save we estimated was around 3.8 million annually from that. So if we're looking into it at a discount rate of a 14–15%, we're talking about 13 million or so over 5 years. A pretty decent savings, or pretty decent value. Well, recommendations, and that's all it was at the first part. In a nutshell, it was first of all to decrease the sample size significantly. Use a flat nonconformance rate across the facilities, which would be the easiest to implement, we thought. We recommended a standard random sampling procedure and auditing process. We all know in the real world random doesn't really occur, and it's tough to get it to happen. More on that in a bit. And to start tracking the nonconformance rates over time, in this case on a control chart, but heck, even if you start doing it on a time series plot, that's going to help out immensely. And finally, you need to test this out. You can't just do it across the board. So we really pushed hard for a pilot study that we actually got to take place in, or we actually got to take part in, I should say, which is wonderful. So again, sort of the natural recommendations are, okay, yes, change the sample size, but what's more important is make sure you're sampling correctly. Use some random procedures, standardize those across the board, and then also to start looking at this over time, so you can start to understand why you're finding these nonconformances. Sorry. Okay, let's talk a little bit about the pilot. Let's move on into that. So once the initial study was done, we got to go into a pilot, and again, I haven't mentioned this before, but the data that you're seeing right here are the result of simulated data, but they are very representative. The numbers aren't exactly the same as were in the study. They are extremely representative. Okay. In the pilot, we got to go to a single facility. This happened to be a 2-building site in the Northeast, 2 warehouses. I got to get steel-toed shoes and everything, which was a hoot, and work alongside auditors and learn all sorts of things about the process, which was really, really cool. And right off the bat, you really learn, as you always do, when you go onto the plant floor or into the office or in the lean phrases or Six Sigma, you go to Gemba, you go to where the action is. You learn different things. Well, here are a few of the key learning points. First of all, there were different measurements that were being taken. We had looked at something called nonconformance rate, which looked at errors, essentially. But they weren't looking at just errors. They were looking at net shorts. More on that in a little bit, but essentially, and I'll cover this actually in some detail. There are 3 different types of errors. There are overs, where I give you too many boxes, where I give you too many cases of something. There are shorts, where I give you too few, and there are mispicks, where I give you the wrong one. We had looked at adding all those together as errors. They're all errors as far as we were concerned in looking at it. However, what was being measured as on the quality side was the net shorts, and there was a reason for that. There were different perspectives. First of all, when we went into the warehouse, we clearly saw that the general managers there had very different concerns than we did, certainly than audit did. In a lot of cases, audit is the boiler room operation anyway. So we really had to show that audit can deliver some value for them as well. And we needed to produce real procedures, artifacts, and policies. So the randomizers that we brought and the SOPs that we brought and the processes that we brought, guess what? They didn't work. They sort of worked, but they didn't perfectly work. We had to work them out. We had to go through and learn the things that dispatch or transportation actually hid certain and kept certain trucks out of the truck paperwork out of the mix so that drivers could go early. We had to find that out the hard way, or the good way, I guess, by being right there. So anyway, the pilot was a big success in that it showed that we could actually do it, that it made some sense, However, it contained more than a few surprises. I'd like to take you through some of those. So here are some of the other filled in the blanks that we got. First of all, we found out that the net short versus nonconformance, what type of contract that the client had or the customer had, was driving a lot of this. We found out that there was a big difference between something called invoice and piece count audits that I'll talk about just in a moment. We even found that day of the week was kind of important because it turned out that there were different volumes of deliveries on different days. And it didn't even have to do with the customer that we were looking at. It was for a different customer. But the data actually showed it pretty nicely, and it helped us craft a solution then for that pilot site and then for the entire company. So some concerns that we determined that we didn't know going into it from the client side was, will the change affect something known as standard credit? So unbeknownst to us, the initial work that was being done was they were looking at something called standard credit. Now, instead of paying claims directly, what they might do for small claims, like if I didn't include a case on a truck shipment or something like that, the company wouldn't necessarily have to make a claim because it would be covered in what was called standard credit, which is just essentially done by auditing a number of them, looking at a net difference between overs and shorts over a certain period of time, and then crediting or debiting, depending on whether the net is positive or negative, to various accounts instead of making those claims. Well, so you can see that that sort of thinking is going to change how you do various things. Client was also worried about or concerned about, was the change workable? That is, we know that auditors, if we're talking about reducing the amount that they sample, they're going to start thinking about their jobs. Is this something that I'm going to be able to handle the change? Am I going to still be here? Those questions. On the customer side, they also had the question of whether it was going to affect standard credit and whether it was going to improve quality. So they said, well, you know, I don't really care if you're saving money. I want to see my stuff get better. So a concern of theirs was to say, okay, are you just going to take a windfall of saying, hey, we're going to reduce the sample size, or are you going to actually do it for our benefit? Okay, so I want to take you through to understand some of the results that I'll show you. You need to understand what are the basic measurements. By the way, I should mention that damages are also a major part of any shipment, and by convention, the error rate doesn't include that. Now, we may argue about whether that's the right thing or wrong thing to do. Damages were evaluated separately. I want to be clear and just do error rate, which consists of over, shorts, and mispicks. So, in a nutshell, I've got those defined down there. So overs. Let's suppose that a Stop and Shop wanted 50 cases of Heinz ketchup. An over would be if you ship them 51. A short would be if you ship them 49, and a mispick would be if you ship them 49 cases of ketchup and 1 case of mustard. Hopefully that makes sense to everybody. They're all errors, but looking at the net shorts, which is really essentially shorts minus overs, gets you to think in a different way. It's if I wanted a case of ketchup and you sent me a case of mustard, if I'm the supermarket, that presents a lot of problems for me because I've got to store it somewhere and I've got a hole on my shelf. But from the point of view of, hey, we're just looking at the net shorts for standard credit, it's a different ballgame. It all works out in the wash. So it led auditors to be measuring things differently. They were looking at something called a piece count, whereas they would just simply look at the number of boxes that were supposed to be on a truck, count them, and if they got the right number of boxes, they were good to go. If they didn't, they would figure out whether they were over or they were short. That's essentially what was going on, and that was a piece count. On the other hand, The error rate, which is something that we define, which is essentially a combination of the overs, shorts, and mispicks, would lead you to something. You can only determine mispicks by looking at invoice audits. That is, I need to know that you wanted ketchup and I gave you mustard if I'm going to figure out that there was a mispick there. I have to know that. Okay, so hopefully that all makes sense, or is at least clear as mud. The point is that their quality thinking was on the net shorts side, not on the error rate side. And that presents a problem. Now, the net shorts may be a great business solution in terms of accounting and in terms of billing and in terms of all that kind of stuff. Short term, dealing with that, wonderful. But from a long-term perspective, it doesn't lend itself to being able to mitigate and find errors. So it's not really a quality strategy. And what was in fact happening, which is shown kind of on here, is the net errors were very, very smooth, but the total error, I'm sorry, the net errors, yes, the net errors were very, very smooth, but the total errors were not. And so what the customer was mostly feeling was on the right-hand side, whereas what corporate was seeing was on the left-hand side. So things seemed very calm over here. On the other hand, on the customer side, on the supermarket side, things were a different story, and that was causing a lot of friction. Okay, and like at the bottom, that's exactly what I just said. The idea of using standard credit or something based on net errors to determine how claims are paid, that's a reasonable thing to do. It's not an unreasonable thing to do. But in terms of managing the quality of your warehouse, you need to know to a higher degree what's going on here. For example, if somebody had I don't know, Ken's salad dressing right next to Wishbone salad dressing, and they were labeled very similarly and they were very easily mixed up, it'd be very easy for the picker or the selector to send the Ken's salad dressing instead of the Wishbone. And sometimes if you can see how warehouses would be set up that way, because it makes it easier from a management point of view, from a conceptual point of view, to put things that are like together, and yet it could create some mispicks. I think that there was I heard a discussion of this from a much more serious situation in pharmacies, where they mix up, where I guess a standard practice in some of these net pharmacies, internet-based pharmacies, is they mix up the alphabetical order, because I think in the 90s, marketing studies showed that people liked science-y sounding names, like, and those tended to start with X's or Z's, so there were a ton of different drugs that sounded the same, and they were being filled incorrectly. So by mixing up the order, it helped that. So this would be something that you could see if you were invoice auditing. Okay. To take you through some of the other things, the perspective of net shorts and doing piece counts made it seem like people were not, that mispicks were not a big deal. What turned out that when we looked at it, that mispicks not only were a big deal, they were the biggest deal. So it was the most common thing, and it was the biggest overall. You can see that overs, pretty rare, which kind of makes sense, right? If we're going to protect ourselves, it kind of makes sense. Shorts were a little bit more common, but mispicks happen fairly often, and they were the biggest of the three categories. Some other findings. Here was the one that I found was kind of interesting. We found that day of the week, mispicks were more common on Mondays, Wednesdays, and Fridays, particularly Fridays, than the others. And these were, but they were borderline significant in the pilot. We did pairwise comparisons on those. And we found also that for invoice audits, not only did they produce better measurements, but people took more care, and they've actually found more errors, which is not surprising. They found more errors on the order of, say, a case and a half per 1,000, which doesn't sound like a lot, but if you're talking about moving 1 billion cases in a year, that's a lot. That's a lot of mispicks. That's a lot of mustard for ketchup. There was a concern that standard credit was going to change quite a bit. You can see that they tracked pretty nicely during the pilot. So that was something that we were able to happily report on, that there wasn't the significant difference between standard credit if we were using invoice only, which was based on the statistical sampling, and all the audits. An interesting thing is that because it was being measured, it's often said that what's measured gets done. I'm not sure that that's entirely true, but in this case it certainly was. That mispicks actually went down during the pilot period. They consequently went up afterward until we did the full implementation. But it was actually statistically significant, whereas the differences of shorts and overs were smaller and also not statistically significant. So anyway, so those were just some of the results, and I've shortened some of these. But the bottom line was that we demonstrated in the pilot that this was viable. There were, however, some issues that were uncovered and some issues that would be there for the full implementation. Some of those were trust issues. For example, the randomizer that was used, there were questions about the transparency of it. And remember in the beginning I had told you that the trucking company is is sometimes owned by the wholesaler, sometimes owned by the customer, sometimes independent. Here's where it came into play. There's a trust issue. So suppose that the wholesaler owned the trucking company, if the trucking company knew the schedule of the audited loads, does that mean they could tip off the selectors to take better care and pick better for those loads versus the other? So there were issues like that. And so one person actually went as far as saying that this was like the Diebold machines in the election of Florida in 2000. So we went to great pains to demonstrate that it really was a random procedure and it was producing random numbers to a high degree. In any event, we move on to the full implementation. Now, to get to the full implementation, what we needed to do was we needed to really make a sale of it. Hey, we ran this pilot. Who's going to benefit from it? Well, the wholesaler needed to benefit. That is that the wholesaler would derive from this a capacity gain. That's what we would call a business case. Business case being anything that improves revenue, improves margin or profitability, or decreases operating costs. In this case, we're decreasing operating costs by capacity gain primarily. That it would improve quality, and then it would provide a more trusted and transparent measurement, including the measurement for standard credit, be more trustable. Supermarkets would also benefit by improved quality by 100% invoice audits, which was something that they wanted because it gave them more information, and by better focus on the problem areas. So that's what the full implementation was all about. Now, we ran the implementation over the course of a few months, and we're able to get it to the point where Straight Line helped them with the first 8, and we were able to transfer everything, writing all the SOPs, the standard operating procedures or policies and procedures, writing all the control chart generators, training people to use a control chart on a whiteboard, including a QSUM, and it worked. As well as writing a number of the procedures for what happens when you're out of control, who gets contacted, what are the root cause procedures that you use, how does it get mitigated. So all those things we did locally at a number of places, and we also built some of the dashboards for the reporting that would happen. We're able to transfer that to the company, and they implemented in the rest of, or they're implementing on the rest of them. It's still going on. So not only did we find out in the full implementation that there were some other drivers, some of the other ones that are listed are commodity. What I mean by that is we certainly found out, I found out this summer when it was in the middle of the 90s, it was like 95 outside. I got to work in a freezer at 20 below, which was a lot of fun, wearing mucklucks and a thick jacket. But selector turnover was huge as well. So if we went to a facility, we found out that there were a lot of selectors, or they were on the ramp of hiring selectors. That was going to be a major driver of the quality that was going on. Also, the number of crews. If they had 2 crews, not surprising that it may differ by shift. So it turned out in a lot of cases that the night shift was staffed with people who were not really trained. And so simply training improved an awful lot in terms of how they did the audit, were they using standard procedures, and so forth. Now I'll be pretty quick with this, but essentially phase 3, which was a full implementation, was all about understanding who the players are and delivering the goods to each of those players. So on the wholesaler side, we've got corporate, regional management, and regional auditors. On the supermarket side, we've got corporate, regional management, and local auditors. And I put for all these different plants, for every single plant, we had a plant management, which was called the general manager and his direct reports, or her direct reports. I think they were all his in this case. There's receivers, there's selectors, there's loaders, and as well as the auditors. So all of them needed to be involved in the solution. So just to kind of go through a very quick who needs what. So you can see it in the middle. What I put together was here are the artifacts that we had to develop and deliver for the full implementation: a sales PowerPoint deck, a corporate dashboard, a customer dashboard, business case, implementation schedule for when it was going to be rolled out, staffing models for each of the facilities, audit schedules for each of the facilities, how to capture the data. I'll just say that there had to be a lot of improvement in terms of how it was captured and sent up to corporate and how they did the reporting. And then the regional reporting as well, changing the way things were reported to more graphical, more easily accessible analysis rather than tables that really were just snapshots of a day, which tended to make people reactionary as opposed to more thoughtful in terms of how they develop root cause solutions. Local schedules as well, and you can see how they're connected to corporate. So, or to the wholesaler, you can see that corporate is mostly interested in the sales point deck, the corporate dashboard, the business case, and the implementation schedule. Whereas regional management more on the implementation schedule, staffing model, how is this going to change my world, right? And so forth. And on the supermarket side, you've got similar sorts of things. Management is more interested in the, hey, what's in it for me, and can I see that it's actually working? How do I know that it's working? And so forth. And then finally, at the local, at the plant side, we developed all of these different things and more, number of different artifacts that we had to develop by plant, random load selectors. So how do we determine for the week, which loads are going to be sampled, what times are they going to be sampled, which shift is going to sample them, what are the sample size guidelines? So one of the things that we needed to develop was a sliding scale for what's the margin of error that we really need. If our error rate is fairly high, what we are really doing if we want a small error rate is just sampling a ton. It doesn't really make sense. What we really want to know is what's the problem, where's the problem, and to do that we don't need to sample a heck of a lot. So there was a sliding nonlinear scale that we developed for that. Daily checklists. What are the things that at the auditor side that they need to do with their team? How do they make sure weekly that they're converting their capacity that they're now saving by not having to audit as much into improving the warehouse? Are they going aisle by aisle and doing audits that way to see, how many damages are in the Ken's salad dressing, not meaning to pick on Ken's, but boy, uh, their packaging leaves something to be desired. Daily reporting, what are the things that they need to report up to corporate? The mappings of the delivery, how do we maximize the coverage schedule so that we can get the best representation of the trucks that are being delivered? Standard operating procedures and policies and procedures, weekly work targets, control charts, procedures, training for everybody on all of that, forms for filling out the data, and root cause guide. So lots of different things. There was more than this, but this was just capturing the highlights. So all of those things needed to be done, and they needed to be done very quickly and implemented very quickly in a number of different sites. It was a lot of fun. It was a lot of work. It frankly was a lot of engineering because you need to make it work. A lot of it really is informed by the statistics, and I'd like to just speak of that in just a moment. So we've walked through the whole thing from soup to nuts, from when the initial from the initial request came across, which was just, hey, can you guys take a look at the data, to okay, let's come in and see if we can make this happen, to okay, now we're going to make this happen all the way across the board. I mean, that's how you actually deliver the value. We were saying that this was going to be 3.8 million annually, or roughly 13 million over 5 years, discounting future money. You know, how does that happen? Well, it doesn't just happen by doing a study. It happens by making it work in the real world. By not just recommending, hey, use a control chart, by going in and making sure that people are using it correctly, and that they're deriving the value from it. So is it statistical engineering? Well, I think it is. I mean, there wasn't a heck of a lot of, what I wouldn't say is there was publishable statistics that was done in the that would be publishable in ASA journals. However, there was significant thoughtful design in sample size calculation. I mean, clearly there was a lot of design of measurements, what's being measured where and for what. I just took you through one type of audit, but there were many such types of audits. Opening up the truck is one of them. Pulling over a selector who's selected a pallet is another one. And there are a large number of other types of audits that can be done. We had to develop the measurement procedures for each of them, what to measure and when. Developing a random selector that was going to work in the real world. It wasn't completely random, but it did a pretty darn good job over time. That took a lot of art and a lot of work. Obviously, the data analysis, dashboards, and all that. And a lot of that is kind of represented in the collage that's over here. But I also want to make the case that, and I hope that all of you take this to heart, that on the business and the customer side as well, there was a lot of statistical acumen that went into that, and particularly in building the business case and the capacity models, the schedule coverage optimization. Those three things made a big difference. Knowing some statistics, knowing some mathematics made a big difference there. I think just just simply in estimating, if we can improve on the on how many people do the business case, which is just to say, well, just give me a ballpark estimate for the number of hours. You know, we can put in a high, medium, low, or we can do a Monte Carlo analysis of that. We can do it in a way, if we're savvy about it, we can do it in a way that really adds value. So anyway, I would like to make the case that it's not just on doing the statistics and the process maps where we can add value. It's also learning your way around the spreadsheet, learning your way around understanding how to have a good conversation with a finance guy and high-level executives as well. Statistics can be a huge aid to all of that. So at that point, I think I've taken through an awful lot there, and I will open up to any questions that you have.
Okay, well, thank you, Mark. By all means, if anyone has any questions you'd like for Mark to address now, please go ahead and submit those through the questions portion of our chat, and we will answer those. So we do have one question already, and that concerns slide number 34, Mark. It says many different measurements and visuals were there for reporting. What IT infrastructure had to be developed? And was it an adaptation of something that was already there, or was it something all new? Was it done in Minitab?
That's a great question. Let me be a little bit blunt. They were doing the way that they were getting their data to corporate was they were faxing. They were handwriting things and faxing. So improving on that was not too much of a stretch with spreadsheets on that. The corporate reporting was done in Excel. So we didn't use we did control charts. All the control charts were done in Excel, and they were essentially handmade and given as templates to people with a little bit of Visual Basic in the back. So that's how they were done. And at corporate they were programmed in, I believe they were programmed in FoxPro. I wasn't privy to that in terms of how they rolled up all the data.
Okay, thank you. If anyone else has questions, please go ahead and put those through. Okay, well, if we receive any more here at the last minute when it's too late, I'll be able to share those with Mark. Otherwise, thank you, Mark, for being our presenter today. This is kind of the first webinar we've done that's an example of a type of statistical engineering, and we're hoping to bring more case study type webinars in the future. So please, everyone, look for those, especially early next year. Otherwise, I thank everyone for attending, and please keep an eye on our newsletters and our LinkedIn group, as well as other ASQ Stat resources for future webinars. So thanks again, Mark, and everyone have a great day.
Okay, thank you. I appreciate it. Thanks for bearing with me today.
All right, no problem. Bye-bye.
Take care.